Hi, so this is going to be a quick tutorial on how to do the GIS work for the Vermont Zoning Atlas. And I'm going to be doing everything manually today, even though the workflow offers the scripts. The scripts are all available on the GitHub page in the Zoning Atlas folder and ArcPy right here. The reason I will not be using these today is because one, it's good to know how to do it with and without the scripts, and two, the scripts can be a little finicky if things are not correctly named or for one reason or another. So the first thing to do is to pick out the jurisdiction that you want to work with. I wanted to work on Rupert. So the first thing to check for here is that we have an uploaded tiger boundary, which is this black bar thing, and that's really important because it's just important to know that we have everything here. So now that we know that, we can open up ArcGIS Pro. I think technically you can do this through QGIS, but I do not have a ton of experience with QGIS, and for the most part ArcGIS is going to be easier to work with. So signing in to ArcGIS, and once this loads, we're just going to make a new project. We're going to name it the jurisdiction, so Rupert, and then we're going to put this under its own folder. So if I pull up File Explorer here, because I'm a student at the University of Vermont, I have a GIS assignments page, and I just created an extra folder for this zoning atlas work, and these are all like the jurisdictions that I've worked on in the past. So we've created our new project, and this is great. Once it loads, just make sure everything's working. The first thing we want to do after this, though, is to create a downloaded folder to store all of our temporary data. So back to File Explorer here. We're just going to open Rupert and create a new folder, downloaded. Oops. Oh gosh. One moment. I misspelled it. This is somewhat important for if you are going to use the scripts, because everything has to be spelled correctly, so just make sure you know what the script is actually asking for. Alright, cool. Now, one last thing before we move on, quickly go down to Properties here and change the coordinate system to 32145, which is the NAD 1983 state plane for Vermont. And this is important because we want to make sure that all our data is in the right datum. And you can quickly check that everything went through, because it'll be this sort of oval shape instead of a square, which is what it defaults to, the 1984 Web Mercator. So anyways, let's go back to the National Zoning Atlas editor page, and we can click Download Jurisdiction Footprint right here, and that'll give us a little JSON, or GeoJSON I should say. And this is important. We can quickly cut this, put it into our newly created downloaded folder, and we can leave that there. Come back over here, and in geoprocessing, go from JSON to features. And this is just going to let us have our jurisdiction outline. And you'll often find that this will not match up to exactly what the maps will have, and that's because these tiger boundaries are created by the federal government, so they can be a little out of date, but they are standardized, which is very important. So I'm going to quickly project this, because right now this is in Web Mercator. So from here I can project the tiger to tiger 32145, which is basically just to say that we're putting it in the current map datum. And it's going to look almost exactly the same. These changes are very minor, but it's important to make sure that we're being as accurate as possible. So now that we have this, we can get rid of the original tiger, and then from here we can change the symbology to have it be a black outline, and this will help us with snapping later on when we're dealing with the actual districts. Okay, so now we can go to the VCGI Open Data Portal and see what VCGI data exists out there for Rupert. Usually there will be at least a few. So here we have 3 here for Rupert. Sometimes it'll be the same, but for the most part you're just looking for one overlay and one zoning. Not every jurisdiction will have overlay districts, and that's totally okay. So this is what we're looking at for the base districts. Wonderful. And usually every jurisdiction will have an overlay district that is flood hazard and river corridor, but these aren't always necessarily reflected in the bylaws, so you're not always including them. So if we look at Rupert here, we have, let's see, forest conservation overlay, fluvial erosion hazard overlay, flood hazard overlay, and that's about it. So we're not going to include our river corridor, but we are missing a few on here, so it's important that we double check everything we do with the provided map on the Zoning Atlas editor page. And this isn't always there. Sometimes you have to find it in the bylaws yourself, or just honestly look it up. But here we have fluvial erosion hazard overlay. So for now, we can compare this to what's over here, and generally speaking, if the VCGI data matches up with the map that is, either provided through the editor page or you find online, that seems the most up to date, you're not going to need to spend too much time georeferencing everything. So for example, like this one that I've highlighted right here, this is the resource district. And we can see here that that lines up pretty well with this. And if we go over to this top right corner, we can see, okay, this is forest conservation, this is resource, this is agriculture, and does that line up with the map? The answer is yes. Maybe we'd want to zoom in a little bit more on these smaller areas, but for the most part, we can make the assumption that this is as accurate as it can be. So from here, we can click download over here and download it as a shapefile. Same goes for any overlay districts we might find. Again, download it as a shapefile. And then if you go over here, find them in File Explorer, we can cut these and bring them to the same location that we brought the GeoJSON for the jurisdiction border. So Rupert, downloaded, paste these, and then just remember to extract these because these are compressed format. Alright, so now that we have extracted all of our VCGI data, we can go to our database, in this case Rupert geodatabase. We can import feature classes. And when this loads, we're just going to go to our downloaded folder and select the two that we just extracted. But here they are. So there's this one, this is the overlays. And then if we go back one, we get the base districts, and boom. So these will bring both of them into our geodatabase, and we can add them both to the project. And then just like the tiger boundary, not those three, we can project them to make sure that everything is on the same page. So this is what we're looking at right now. This looks pretty good, but obviously this doesn't match up with the tiger boundary, which is in black. which means we're going to have to manually snap this. So if we're following along with the script, we will be right here. We still have to make sure, that everything is in the same coordinate system before we do anything. So let's start by projecting our overlay, and I like to name this something super simple. So these are the this is the base district. Oh no, these are the overlays. So for this, I'll just name it overlay 32145. And 32145 is just the code for the state plane. So it's just nice to make sure that everything is where it's supposed to be. So that's the overlays, and then let's just quickly do the base districts, and I usually just name this after the jurisdiction. So in this case, Rupert. Yeah, so these all get stored in the geodatabase, and you shouldn't run into any issues with renaming or having to rename anything if it's all within the same group. So you can get away with things like overlay underscore 32145 because it's in its own folder. So let's start with the overlay districts because those are going to be a little easier. There's less involved here, and just in general there's not as much priority about snapping with the overlay districts, and I'll explain why in a second. So as we previously established, we don't need these river corridor districts, so if we go into this edit tab up here, we can just delete these and then move on. So we have modify features down here at the bottom. I just have this tab open, but I believe you can find it in edit right here for edit vertices. This is the one that we really want because this will allow us to actually like snap things. So if you have it over here, it's in reshape. Just double click it, and then if you zoom in real close, not a great example, but we could take this flood hazard district and then snap it to the edge here. And just keep in mind that you're going to have snapping for vertex, edge, and I also like to have intersection, and I'll show you why in a second. But basically it'll help you with any districts that go outside of the border. And this is a good time to mention that for overlays this matters much less because this is super zoomed in. The amount that I just moved it right now is probably somewhere around 10 meters, which is ultimately not super impactful. What's much more important is that any districts that go over the edge of the tiger boundary are reined back in. So this right here, it's substantial, but it's not the biggest concern in the world. And if you compare that to, not a great example either, but really it just matters because all these tiger boundaries, and like the reason why we're using tiger boundaries at all is because they all fit together very nicely. So you don't want to have an overlay district that is for Rupert, but let's say spilling into whatever the nearest, oh, that's New York, okay, spilling into, let's say, Dorset, right? Because then the system won't really know how to handle it, and it becomes a much bigger issue. So it's really the responsibility of us right now to sort of collect anything like that and make sure that it's all in the right spot where it's supposed to be. With all that said, this isn't too difficult. However, you have to take into account, and not as much for overlays, obviously, because overlays are much, you're not covering the entire perimeter, but sometimes there will be a vertex in the middle of these 2 points that I just moved. And in that case, you want to make sure that you're also either creating another vertex in the overlay district to then snap to that, or to the point that like you don't have any gaps. If you're trying to get rid of gaps, you want to make sure that you're snapping to every single vertex that exists on what you're snapping to. And this is a good time to point out that there is a snap tool, and it is useful on occasion. I think it's ultimately not the most useful tool because there are going to be times, and here's a good example of it going over, there are going to be times when, more often than not, you don't have an equal number of vertexes for both of them. So for your tiger boundary, maybe you have more vertices, and then you're going to try and use that snap tool, and it's not going to work because you just don't have enough vertices to snap to everything, and then it becomes a whole big issue. Or you might have the opposite problem where you have too many vertices, not everything snapping, and then you still have gaps, overlaps, all these things. I think it's personally easier to just manually do it, even if it takes maybe a little bit longer. So okay, this is our overlay snapped. We're good with that. We can click save in the top here and call it a day. So let's put these back on, and this is going to look a lot more daunting because you have to do the entire perimeter. So if I were to quickly select the tiger boundary, it's a lot of vertices. You know, off the top of my head, I could say there's probably at least 40, 50 here. And that kind of sucks. But keep in mind, you're doing this by each individual district that is on the border. So at a time, you're not probably doing more than like 10. Obviously, depending on the district, and sometimes there are districts that have like a river as the border, and that's not necessarily something you're going to be needing to snap everything to. And that's mainly because a lot of times water is not necessarily any district, so there's no need to go through the issue or go through all the trouble of snapping everything to the river, let's say. A lot of times jurisdictions on a zoning map will denote that, but maybe the VCGI data won't, and that's never really going to be a big deal. All this is to say that it's okay if you have, like, let's say this district, let's say if this one was a river or a lake of some kind, it's okay if it doesn't exist there. It won't always, and it's okay to include it or not include it. It's not like a standardized thing. But anyways, we can, I find it's also pretty helpful to go back and forth. So, you know, I just did this corner and this corner, and now I know, okay, I have 2 more here, 2 more up here. And then by the time I'm coming back here, I can go, oh, okay, well, I have all these extra guys in here. I can delete them. That's not correct. And when you're actually snapping these, I find it's sometimes easier to just like save this edit and then come back and immediately select the same thing. The Edit Vertices tool has a memory of sorts, so I can move this over here and then it will remember where it was at the start of this like edit session. And that can be really frustrating if you have a bunch of vertices that are really, really close to the vertex that you're aiming for, i.e. this one, or maybe like one in here that's a tiger vertex, because your snap tolerance is just kind of too big. It's not always the case, but I find that if you have a lot of them and you're sort of zoomed out, it's nice to just kind of open it and close it, and then it's less nitty-gritty zooming in and out and all that stuff. With that said, I would very much recommend doing this with a mouse. That might be kind of a no-brainer for anyone who's working in a computer lab or something like that, but I'm currently working on my laptop with a virtual desktop, and it's honestly game-changing, especially for snapping. I don't think all of the work for the GIS necessitates a mouse, but it certainly is helpful here. And there we go, that's just one district down. You would continue this for all of them until you get back to this first district that you started with. I'm going to quickly do all that and then come back to you. Alright, so I have snapped everything manually. So at this point we are done with part 2 of the workflow. So we've done all the snapping. This is for if you wanted to use the snap tool. And this is now for running script 2. And script 2 basically just does a little bit of cleanup work behind the scenes. but we can do that all manually. So at this point, we now have a pretty accurate map. It fits everything, but it fits within the confines of the tiger boundary, which is awesome. But the problem is, for the base districts, it's really important that there's no overlap, or there's no gaps. This is obviously, there's exceptions for these. For the gaps, there can be overlaps, or there can be gaps in the base districts if there's some sort of other area underneath it, right? So you can have like open water as an open area. That's not a map district because no one's building on top of a lake anyways. Same goes for sometimes major roads, sometimes train lines like the railroads. It usually depends case by case, and it'll usually be included in the attribute table. So for district, it'll maybe say rail or road. This isn't the case here because, as with most jurisdictions in Vermont, they are pretty remote and they don't have these things. But regardless, you can have gaps for that. And for overlaps, the overlay districts are allowed to overlap on top of other districts. So typically, you want to make sure that you have two separate files, a base districts and an overlay districts. So for now, let's move on to the topology checker. So the first thing we want to do is in databases, we want to add a new mobile geodatabase. And this is important that it's a mobile geodatabase because a normal geodatabase like the one we have currently or any of the other kinds won't let us do what we want to do. And this is specifically because of some UVM restrictions. So we can just name this Rupert, as a new mobile geodatabase, and give that a second for it to load. Here it is, and then we can add Rupert 32145 to it. It'll make a copy of it, so any changes that we make to Rupert in the mobile geodatabase, it will make to the Rupert in the main geodatabase. So from here, we can create a new featured data set that might be cropped, unfortunately, but we can just name this Rupert as well. And it's important that we make sure that this has the exact same coordinate system as Rupert 32145, because otherwise it won't let you use the actual feature class. So this is our new feature data set. We can move this into here, and now we can right click this to create a new topology using this feature class, and we can add some rules. This feature class must not have gaps. This feature class must not overlap. Wonderful. Usually you have to refresh the feature data set after it creates the topology because it just doesn't know yet, I guess. But anyways, here it is. We can add this to the map, and it'll look exactly the same for now. And then we can go up here to our ribbon or edit ribbon, select our topology, and go to Error Inspector. And at this point, it's important that we zoom out a tiny bit so that the entire thing is in frame. And then over here, there's the Validate button, and it'll tell us all the errors. So actually, this looks pretty good. This is very few errors. You'll see with larger jurisdictions, or really jurisdictions with more districts, or maybe sometimes just really poorly made jurisdictions, that there'll be like a lot of overlaps, a lot of gaps, but this doesn't look too bad. So let's start with the elephant in the room. Anytime you do this topology check, you're always going to get a must not have gaps error for the entire perimeter of the jurisdiction. And that is just an error with how the tool works, and you're always going to have to mark that as an exception. So the whole thing is highlighted down here at the bottom under Fix. mark as exception, and then it will no longer be an issue. So for the rest of these must not have gaps, we can zoom to, and for the most part, you're just going to create a feature for these. It's really the only thing you can do. And we'll get to how that plays into other things later. Same for over here. This is another, oh, not that one. This one is another just gap, create a feature kind of thing. And then this one is also on the perimeter, so we're just going to mark that as an exception. And then the last thing I wanted to show here was for overlap gaps. There's really two ways you can approach this. Most often, you're not actually like putting the districts together yourself. Obviously, if you have to manually digitize, it's a different story, and you would know better like which way it's supposed to go if it does overlap. But for the most part, the overlaps you're going to see are just going to be these tiny, tiny little slivers, and you can just merge into the largest. There are instances where that's not the case, but for the most part, you're safe in doing that. So from here, we can just save all of our edits. That looks good. We can close our error inspector, and we can even get rid of our topology. And just for the sake of keeping everything clean, we can get rid of the old Rupert 32145. They are the same thing, but you know, whatever. So from here, we now have a bunch of very similar districts, but they're all their own polygons, right? So you can see here, this resource management polygon, very tiny. It's also the same as this one. It's the same district, I should say, but it's not the same polygon, right? So we're going to have to dissolve this. But, as you might have realized, we did just create two new polygons. Really, really tiny ones, but polygons nonetheless. So before we can merge everything into districts, into one big polygon for each district, we have to eliminate. So we have to use the eliminate tool on any of these districts that we created that have null values. Eliminate, and it's important that you select these in the attribute table, otherwise the eliminate tool has no idea what's going on. So use the selected records, create a new feature class. This all looks fine. The next step here is to dissolve. So the input here would be the eliminate, and this is our last step. So we can name this clean, and our dissolve field can be district. So we can run this, and ideally we should get, I believe, 7 districts. So if we look at the clean one, oh my gosh, we have 12. What happened here? A lot of times you'll get some mistakes in the spelling of districts. So this is Forest Conservation. That's forest conservation. This is forest conservation. This is forest conservarian. Yeah, this happens a lot. You can always just dissolve it again, and it's no big deal. And then that looks good. So we can remove all these other Ruperts. They are unnecessary redundancies. I'm going to quickly delete the clean one because this was also wrong. And then the final one. This will happen from time to time, and it's just good to make sure that you are on top of your files. Nothing is too crazy. So from here, it's generally good practice to make sure that this looks like the map that you started with. So you can change it from single symbol to unique values for your symbology, and change the field to district. So from here, we're looking at this and we're saying, okay, these are roughly what our districts look like. does that match up with what this is? So we've got this big green, there's a little yellow in the middle. Yeah, that matches up, that matches up. How about our light green? Yeah, we have some teal over here. That matches up, this is matching up. We have little pockets in here of varying things. So roughly this looks pretty good, and I would say this is good enough to not require georeferencing. But if you do notice any inconsistencies, it's always good to double check, just because you never know. Sometimes things change, and ideally we're as precise as possible. So then the last step here is to then upload this to the editor page. So for fields, we just need to make sure we have a few things processed. So for one, we need the county name, and this has to be text for the data type. And we also need jurisdiction. Jurisdiction, yes. It's important that you spell these right because you cannot import them otherwise. And then lastly, you have to change the alias for this to abbreviated district name. Alright, we can save this. And then back to here, we can quickly calculate all of our fields. So county, this is in Bennington County. And the jurisdiction is what we've been working on all day. So, Rupert. Alright. And then lastly, you just want to make sure that you're using the right abbreviated district names. So, in this case, agriculture is AG, all caps. Typically, it's bad etiquette in ArcGIS to use spaces, but you don't always have a choice here, and I guarantee you it will not impact your ability to import these. So just real quick, rural, RR, resource management, RM, and FC. Technically it's FCO. I think maybe there was some miscommunications there, but regardless, this all looks really good. Alright, yeah, so now that we have all of our fields and attributes filled out correctly, we're going to do the opposite of what we started with. So we started with a GeoJSON from NZA editor page, and now we're going to do the opposite. So we're going to do features to JSON. And we're just going to do this one that we've been working on. And it's important that we click Output to GeoJSON, project, and use field aliases. This is going to make sure that the editor page can actually read what we're giving it. And it's also good courtesy to just name it the name of the jurisdiction underscore ready to join. And this will just make sure that everything looks nice and neat. So we're going to run that. That'll put it in my file explorer. We're not going to worry about that too much right now. And then the very last step of this would be to go to your editor page, click Import, import zoning district boundaries, your team, your state. For us, that's just going to be Vermont both times. And then this is a previous one I was working on. Let's see, Rupert, and Rupert ready to join. Now, assuming everything works well, it'll hopefully, say updated boundaries for however many districts. Sometimes it'll give you an error message as to like what went wrong. So let's say I typed in one of my districts, let's say my ag district, as AH because the H key is just right there and I misclicked. It'll tell you AH is not a real district or something like that. At which point you could go into File Explorer. You could find your newly created GeoJSON. So I know I just had it there, but you could go to here, and then you can open with something else. So in this case, Notepad++, and you can actually find and replace any instances of a district that isn't real, like AH, and replace it with AG or something like that. And yeah, that's pretty much the entire process. I do want to show one more thing before I end this video though. So on none of these do we have a specific jurisdiction here, or a specific, a specific district within Rupert, and that's the fluvial erosion one. And this will happen from time to time, so this is all the work I just did. This will happen from time to time where the data just isn't really anywhere digitized, but the data does exist. Because if we look here, this little pink line in here and over here, blah, 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 that all exists and needs to be digitized. So the first thing we can do is we can download this PDF into Rupert, wherever Rupert may be, into our downloaded. And we can just name this like Rupert _ map, something like that. And this is going to be a PDF. And PDF is not super helpful for digitizing. So we're going to have to convert it to a PNG. And there's many websites that do this. It's nothing super crazy or intense. But convert. Yeah, so once we have the PNG, we can add that as a raster into ArcGIS Pro, and then we can georeference that based off of the existing tiger boundary. So I'm going to quickly just put this with everything else in Rupert. This part is always kind of tedious, so it'll just take me a second to get it to the downloaded section. All right, wonderful. So now if we go back here, I'm actually just going to close this tab. Sorry. Yes, so we can go to Folders, Rupert, and Downloaded. And we have this little Rupert map.png. Add it to the map. It'll say, hey, we don't have any information on this because it's just a random PNG. And you can just click OK. It's going to do a lot of statistics on it and place it somewhere. And that's fine. I'm actually just going to close this for now. We can even put that away and this one away. So now we can zoom to layer, and we'll see that this is probably in the middle of nowhere. Yeah, the middle of New York, which is cool. So using this, we can do a little georeferencing. So the main thing to do here is to add control points and zoom into each of these recognizable corners. So this is a corner right here. Go back to the tiger boundary and snap to that corner. And then we'll do this about 3-ish times total. Ideally, you want to have a lot of points, but at the same time, you don't want to get too many because there's always going to be a little bit of error in how we place points, especially because, as you can see on this map, the dotted line doesn't really match up with the straight line, and that's because the dotted line represents the tiger boundary, which is why I'm snapping off of those corners. And all this is to say that, you know, we just did all this work to make sure that we're snapping and moving all these vertices around. So any of this georeferencing stuff is going to look a little funny. So I'll just do one more. One for each corner is pretty good. Yeah, that doesn't feel great. We can just put that right there. And then once we're good, there's this little apply button at the top. Click that. We can save. And then typically, it's not going to show up as anything. Even if you like zoom to layer, turn the layer on and off. So at this point, as long as you've saved it, you're pretty much good. You can remove the Rupert underscore map, your raster, and then just add it back in, and then zoom to layer. And that didn't. Oh, here it is. Okay, yeah. So, yeah, these things can be a little finicky. Not sure why it's only working at that zoomed out of a scale. Oh, here it is. Okay, just need a second, I suppose. So now at this point, we're kind of like, we've already done most of our work here, right? So I don't really need this to double check anything. If I really wanted to, I could. I can't really click the raster layer here, whatever. I'm gonna turn this back off. But for the most part, you would use this to double check your work that you've already done, and then also, in this case, to create a new feature layer. So I'm gonna turn on my overlays real quick. We want to add the fluvial erosion hazard overlay zone as its own like separate entity from the existing flood hazard overlay. And they're very similar overlays because they're both following the same rivers. But as I just showed, they're slightly different. Okay, so in the overlay, I'm just going to turn it to about 50% transparency. And this will allow me to look at everything a little nicer. So I want to create a new feature on the overlay, or like within the overlay feature class, right? I'm creating new polygons. So there's two tools here that are going to be super helpful. The first one being polygon, which literally just lets you plot out points to create a polygon. And then the second one is trace. And this is a lot more helpful on the edges of features, especially when you're like digitizing an entire map. Hopefully it doesn't come to that, but it happens. That's not working how it's supposed to. Yeah, so it can be a little difficult to start with. But it comes pretty quickly to most people. I found it didn't take too long. And especially once you turn off snapping for the actual like digitizing process, it's really simple. It's just a matter of like time. It takes a little bit of close scanning, but when you are working on such a zoomed in scale, it's almost never going to matter if the points you plot are slightly off, especially for overlay districts like this one, because they're allowed to overlap anyways. What's more important is that you're including the entire zone. So I'm going to quickly finish this on my own, and then I'll show you how to do the rest of the overlay process. Alright, so I have created my fluvial erosion hazard overlay. I've also renamed all of my flood hazard overlays. And just like the base districts, we can just quickly dissolve all these. We don't really have to eliminate anything with the overlays, simply because there isn't any need to fill space. And yeah, so we can just quickly dissolve all this. And this will only be 2 districts, so it won't be anything super crazy. We'll just quickly take the attribute table here. We'll add county. We'll add jurisdiction. Change overlay to abbreviated district name. And then quickly turn everything else off. Save that. And of course, once all this is done, you can upload it just the same, and it should show up in the same spot. Jurisdiction, Rupert. Alright, save all this. And then quickly features to JSON. And then again, you just do this. I typically like to differentiate between overlays and non-overlays. So I would say Rupert underscore overlay underscore ready to join or something to that extent. Ready to join. Again, it's a GeoJSON, project, use field aliases, and yeah, that's pretty much all you need to know. Thank you for listening.